Welcome, Hornets. We're going to be taking a look at finding inverses when we have functions that are not one-to-one. There are lots of functions that are not one-to-one, and the common issue is we want to avoid the portion of the graph that fails the horizontal line test. In this parabola, for example, we have a graph that looks something like so. Goes through the point 1 comma 0, and it is a double root. You can clearly see that. And it will go through the y-intercept over here at 0, 2. We also know that because if we FOIL it out, we get x squared minus 2x plus 2, and the positive 2 when x equals 0 is what's left, thus the y-intercept. Now our problem is that this fails the horizontal line test. So although it's a function, it is not one-to-one. We have to identify the axis of symmetry. Where is the symmetry that is causing the problem? Remember, it's the symmetry that is our issue. So what we have to do is we have to select one side or the other, choosing which portion of the graph to work with. Now, the most common portion of the graph that we like to work with is the positive side, this portion right here. Okay, so let's just take a look and see how this is going to work. By restricting the domain, we only take the portion of the graph that has the vertical line test solved. In other words, the one that does work. Now you'll notice in this problem, we've taken out this entire half, okay, that entire portion. And if we're trying to go through, notice this graph would continue all the way to that point on our inverse axis. So we're going to find our mirrored image on this side. That's the graph we're looking for. Notice how it is a positive being above. Okay? This portion on this side will represent the second half of our relation. You'll remember these relations from your pre-calculus. Okay? Notice that's the second half of the graph we're not showing. So we're looking at a square root. When we find our inverse will be a square root. Here we go. Given y equals x minus 1, the quantity squared, x equals y minus 1, the quantity squared. Take the square root on both sides. Square root of x is equal to. Now this is giving me a plus and minus. Y minus 1. Notice this plus or minus right here from the square root of something squared came from an absolute value. And that means that this is either a positive root x or a negative root x. Okay? The positive root x goes up, the negative root x goes down, and this will represent our horizontal shift. So we have a positive root x plus 1 equaling our inverse. And this is the top portion. That is this portion of the graph. If we did the negative square root plus 1 equaling our y inverse, we found this portion of our graph going downward, the decreasing portion of the curve, or the negative square root. Notice a quadratic will have a square root as an inverse, but we have to take only part of the square root. Otherwise, it fails the vertical line test and is not a function. Okay, that's the whole issue. And that's what we have to be careful of. That's the idea of restricting the domain, going from the vertex point, choosing the positive side, and then locating that positive equation. Thank you very much.